morning, everyone. Perfect. I see that all of us are in sort of like low energy mode here due to the heat, but it will be okay. So if you're here today, it's probably because you want to know more about Kops best practices, and so on. What we're going to talk about is how me, Andrea, and my company, Camunda, manage Kubernetes cluster in AWS using Kops. Just to give me a quick idea, who is using Kops here? Okay, who has never used Kops and is just trying to get some insight on what it is and so on? Okay, sort of like 50-50. Nice. So yeah, in Camunda we are managing many clusters, mainly on AWS and Google Cloud. The one that we are running on Google Cloud are using their managed service as GKE, and the one that we run on AWS are using Kops. So there are clusters that we provision ourselves using these tools that we are going to talk about. And the talk of today basically aims to give you a quick idea of why we decided to use Kops, which advantages brought to our infrastructure, and some best tips that we built during the years. We have been using it for several years right now, and yeah, following this path, we managed to break it multiple times, we managed to fix it multiple times, and we developed some best practices that you should probably use as well if you're planning to run Kubernetes container using Kops in production. A quick intro. So what we're going to talk about will be how and why everything started, what was the problem that we were trying to solve, and how we decided to solve it. We will have a quick introduction to Kops. Some people are already familiar with it, but basically Kops stands for Kubernetes Operations, and it's a tool that allows you to deploy clusters on different clouds. AWS is the most popular one, but of course you can deploy your own cloud even on Google Cloud and not use their managed service. There might be different reasons for you to do that. We will also go a bit in deep into that. We will look at integration with different AWS services, so how you can integrate services running on your cluster with, for example, RDS or Lambdas or load balancers and so on. And then we will basically say a list of pros and cons that we found. In which use case you should definitely use Kops, in which case it's probably not a good idea for you, your company, and your team. Just to give you a quick idea of who am I and what am I doing, I work for a company called Camunda. We're based in Berlin. We do workflow automation. This means that we build a software that it's open source. So feel free to go on our website, download it, and use it for free. That can automate complex workflows. So you can write workflows in a notation, a graphical notation called BPMN, which is really nice and really easy to understand, especially when you have a very complex workflow. And our engine basically automates it for you. This is sort of a framework, so you have very different use cases. Some of our clients are e-commerce, tracking, for example, the status of a package shipping, or insurances, tracking the status of their insurance policies. So it's really like a very different kind of market. We really go from big companies like Sony to small non-profit in South America, and this is all due to the power of open source software. As I said, we're specialized in workflow automation, but most of our clients deploy our software in their own data center, on their own infrastructure. So the majority of our workflow is mainly CI/CD. We run very large CI/CD pipelines. One of our biggest Jenkins systems has around 2,500 individual jobs, and we run thousands of builds per month on Jenkins on Kubernetes. So as I said, CI takes the majority of our computing infrastructure. We don't have any super high traffic public service. But a couple of years ago, what happened is that this guy, anyone know this guy? He's called Daniel. He's the CTO of Camunda. He came to me and he said, hey, Andrea, listen, I have an amazing idea. So Daniel is a really nice guy, and he has a lot of ideas. And it was just one of the thousands of ideas that Daniel has during the year. And he was like, okay, yeah, sure, tell me. It's like, I think we should build our own SaaS. I think we should give away to our clients to not only draw this BPMN diagram and send them to each other by email. I want them to be able to draw them online. And it was sort of, what? We have no experience running public services at this scale. We just do CI/CD. We do it really well. We can do it very efficiently, with a low cost, with many different environments and so on, but we actually have no experience running this kind of products online for our clients. It was like, yeah, no worry. It's going to be amazing. I'm sure that we will make it. I'm sure it will be great. And I'm sure all our clients will love it. And that's how the Kawimo project started. So Kawimo.com stands for Camunda Web Modeler. What does it mean? It means that what we wanted basically was a product that would allow people to draw these diagrams online, like for Google Docs. So when you open Google Docs, you can write a text file or Excel sheet or a presentation with your colleague. You can all invite them to the same presentation and collaborate in real time. Kawimo does the same thing, but for BPMN diagram. Then you can export it and import it in our Camunda software. It was actually a great idea because there was no tool like that. Our clients used to model their diagram locally and then ping-pong to each other via email, creating different versions. It was commenting on diagrams was getting really tricky, and Kawimo was actually solving a problem. So we started working on it. We started prototyping. We created a team of developers and operations people working on that. But yeah, we started basically managing things the way we were used to do that. So just using Terraform, normal EC2 instances, and so on. And things were working quite well. But as you know, we still consider ourselves a startup. We are 120 employees at the moment. We have many clients, but we still keep this startup mentality for which we always try to innovate and make something new. And whenever you innovate and make something new, one problem that you have is that the requirements are not clear. So services started to grow, requirements started to change. One day the developer needed an environment with this kind of setting. The day after, they didn't do it anymore. And then the week after that, they maybe needed the same environment with twice the amount of resources. And managing all this using plain Terraform, plain EC2 instances, and so on was becoming really hard. Basically, what we noticed is that very soon, all our code was sort of something like this. So just a mess of spaghetti code, modules, sub-modules that were inheriting from each other, a global state on Terraform that you would then use in 3 different environments. Everything was getting really, really complex, mainly due to the fact that, as I said, requirements were changing, and we were not really sure in which direction we wanted to bring this product. So what we eventually figured out is that maintaining an infrastructure with constantly changing requirement is really, really complex if you do it in the traditional way. With the traditional way, I'm saying without using Kubernetes, let's say. So managing your own load balancer, managing your own security groups, managing your own EC2 instances, and so on. Because as soon as a service starts to grow, you need either to run it in multiple nodes or create a bigger EC2 instance, and so on. And Kubernetes sort of abstracted that for you. On top of that, it was getting like really complex. All the code was really getting messy, really, really fast. And we decided, okay, we need to do something at this point. We cannot postpone this anymore, because I mean, the plate of spaghetti that I showed you before was really beautiful, but you don't want it to turn into something like this, So that's what we had. So this was our motivation, this was our idea, and this is why we wanted to go in this direction. We wanted to try something new, and we wanted to experiment, first of all. The code was becoming difficult to maintain. Capacity planning with changing requirements, it's really hard. So what was good today was not good the week after. And yeah, new ideas were constantly coming from a developer team, so we always needed to act fast in order to deploy a new service, new Redis component, new database, and so on. And that's why we started having a look at Kops. So in Camunda, we have this tool that all our developers can use. It's called Slack Days. Basically, you can take up to 2 days per month for your own personal development. You can basically ignore all your tickets for 1 day and focus on something that brings value to you. It can be a new tool. It can be a new feature of your favorite programming language. You can work on your personal project, IoT, open source project, you name it. And at that point in time, I always heard about Kubernetes. People are using Kubernetes everywhere. But I didn't actually know about it. I read something online, but nothing more. And together with a colleague of mine, we basically took a Slack day together. And we decided to set up our first Kubernetes cluster, dig a little bit into the abstractions and so on. And we started doing that using Kops. Kops, for people that are not familiar with that, stands for Kubernetes Operations. And basically, it's a tool that allows you to spawn Kubernetes cluster in different cloud providers in a self-managed way. So you are basically using the native EC2 instances or the native virtual machines of Google Cloud to spawn your own Kubernetes cluster. It's really easy to use. It's a CLI tool, so you can use it directly from your laptop. And believe me, creating our first cluster was really, really, really easy. So you just Kops create cluster, a couple of credentials, and everything is set up. So Kops makes it really easy to create, destroy, upgrade, and maintain clusters on different cloud providers. And we started basically playing with that. We created our own cluster, deployed our own application it a couple of times, and then just tried to, okay, let's try to click and destroy this instance, and click here and there. And basically, it works in the beginning. The pipeline is always the same. You build something, you destroy, you break something, you destroy it, and then you build it again. So even tearing down and creating the cluster was really easy with Kops. After that, looking a bit more into the tool, something that was definitely for us a winning point was the export to Terraform. So this allowed us to understand what Kops was doing under the hood. Because, okay, it's cool to have a tool where you just write Kops, create cluster, and automatically a cluster appears. But if you're going to run it in production, you probably want to have some ideas of what this tool is doing under the hood. And as I mentioned, we were already familiar with Terraform, and the Kops export to Terraform is really great. It really allows you to understand what is running underneath, and it really allows you to have the sort of infrastructure as a code approach that all of us are looking for. The learning curve is extremely shallow. So as I said, creating your first cluster is super easy, and in a matter of minutes, you will have it up and running, and you will be ready to get tested, and then you get started. You can have different network topologies. We're going to talk about that a little bit later. So you can create private cluster or public clusters. Public clusters are much easier to set up. They're a bit less secure, meaning that every node is exposed to the internet, so it's accessible from the internet through SSH. Private cluster instead have a more complex network architecture, but they're definitely the way to go if you're looking to run some production code on it. And what we liked as well was the very active community. So we realized immediately that there was a very active community behind that on the GitHub issues, on Slack channels, and so on. And the project was actually really, really active. I mean, people were developing new features all the time, creating new integrations for different components of AWS or different clouds as well. And how we started, as I mentioned before, is just one step at a time. You build something, you break something, and you repeat many, many times. And that's what we did basically in the beginning. We started running some very low priority workload on it, started breaking things, and then basically learning from our own mistakes. And that's the way we built some knowledge about it before going full on it in production. We also needed to understand if this was really fixing the problem that we had. But yeah, I mean, slowly we started building more and more best practices and tips to manage your own Kops cluster. And right now we sort of have an idea of pros and cons of this tool, why you should use this tool or why you should not use this tool. Why you should? So it's very easy. I mean, it's really not difficult at all to create, modify, and destroy your own cluster, especially if you use some infrastructure as a code approach. Basically, you have your whole cluster definition in a YAML file. You can set up different node pools with different resources in different availability regions and so on. Everything is extremely intuitive. There is a very active community and development that I have to admit helped us a lot in the beginning whenever we were trying to set up some more complex network architecture. There is full transparency over the infrastructure details using Terraform export. As I said before, this was definitely a winning point for us. You don't want to run something in your infrastructure that you don't know how to fix. And when something breaks, you need to know where you need to look. You cannot just let the CLI do all the work for you. It's possible to build your own custom images from master nodes. So by default, it will pull the custom the AMIs that are provided by the Kops project. These are maintained by well-known Kubernetes maintainer and so on. But you might have different requirements. So you might need to install different packages on your master nodes and so on. You can do that. So you can build your own AMIs and save them in your local AWS account. And we will have different network topologies. We will speak about that later. Why you should not use Kops? You should not use Kops because the release cycle is a bit slow. So In general, what happens is that when Kubernetes 1.15, for example, is released, Kops starts to support 1.14, so they always stay one version behind. And while this is not really a problem in our case, I can imagine that for some of you this might be an issue if you want always to be on the latest version. So be careful, because in general you will always be a little bit lagging behind in terms of Kubernetes version. For some use cases, it's also probably not flexible enough. For this, I mean, if you need to set some specific API servers flags, if you need to have some specific network configuration, and so on. Kops is extensible. It allows you to have many different things, but it's not as extensible as running really, as deploying your own cluster using Ansible with your own manifest and so on. So there is some extensibility. It's a little bit elastic, but it has its limits in this sense. Okay, now we're going to speak a little bit more about Kops and its integration with AWS. So how does the cluster integrate with different AWS services? We will talk about VPC and autoscaling group, first of all. Then we will speak about load balancers. And then I will spend a brief time about RDS and Elasticache. So talking about VPC and network topology, as I mentioned, there are two main network topologies that you can deploy, public and private. Public network topology is the default one. So if you want to build like a throwaway cluster, a testing cluster, and so on, that's what you should use, because it makes it really easy if you want even to SSH into a node and just have a look at what's happening. The disadvantage of that is, of course, that everything is public. So your master is public, your nodes are public, everything is accessible for the internet. So as I mentioned before, if you're running some production workload, you probably want to go with the private topology. Private topology is quite more complex, so it includes a public network, private network. All the nodes are not accessible from the internet. And basically, Kops sets up for you a bastion host that you can use to access your network from the outside. So it's really nice because you have only one point from which you can access your infrastructure, and then you can put on that particular node some intrusion detection and things like that, so that you are sure that your network is actually isolated from the internet and people are not trying to break in. This, on the other hand, is much more complex. You will see that the Terraform file is like 3 times the amount of line than the public topology. But yeah, it's definitely an effort that you should consider whenever going to production. In general, what we suggest, what we found as a good pattern for us is having one VPC per Kubernetes cluster. Some people deploy their Kops cluster in already existing VPCs with other resources. You can do that. We don't really advise you to do that. We had some bad experience with it. Also, the advantage that we found is using the peering between VPCs, it becomes really easy to let a different cluster communicate. What we do in our case is that we have 3 different clusters, 3 or 4, you name it. So we have one ops cluster that keeps your logging, your monitoring, your CI/CD servers, and so on. Then we have one dev cluster that we use just for developer environments, so that they're easy to be created and destroyed. We have a staging environment that represents like production, just in a staging fashion. And then we have a production cluster. The advantage that we have using VPC peering is that each one of these clusters is isolated in its own VPC. And using VPC peering, we let all the clusters, so dev, stage, and prod, communicate to our ops cluster. Why this is an advantage for us? Because you can expose then public and private load balancer on your ops cluster, and you can create basically internally available service. This means that, for example, we get centralized logging and monitoring out of the box. So all our clusters are basically shipping logs through the internal network to our ops cluster that is running an Elasticsearch cluster, basically. And still, you are keeping all your cluster very isolated because they're all running in different VPCs. For example, you cannot go from the stage cluster to the prod cluster or from the dev cluster to the prod cluster without passing also by the operations cluster. So it's always an extra step in case an attacker breaches into your cluster. You still have a bit more. You will still make his life a little bit more difficult, you know. Yeah, as I mentioned, you can expose using private topology internal services, using internal load balancer, and this comes unified logging and unified monitoring, which is really nice. In terms of load balancer, there are different types in AWS. ELB are managed out of the box. They work just great, and they're super stable because they're the oldest one. NLB support is currently in beta. We are using them. I mean, you know that in the Kubernetes world, basically beta means stable. So we are using them, and they're working quite well. NLB, they need an external ingress controller. So here in the slide, I put 2 of them. You can check them out. We have been using for a while the Zalando one. So it's the first link. It works really well. Basically, you will have a controller running on your Kubernetes cluster. And this controller will create for you additional resources, like in this case, ALB, so Application Load Balancer. If you're working with RDS and Elasticache, the integration becomes really easy if you're using the Terraform export, because then you have access to all the security groups and so on. So you can just take Kops, export the Terraform file, and then add more Terraform files to the same folder and link them using the security groups and so on. If you're really adventurous and you like Adrenaline, you also have an operator for that, so you can deploy your RDS from inside Kubernetes using a custom resource. It's really beta and it's really experimental, but it may be a nice idea if you want, to break your cluster, basically. Give it a try eventually. So the result, what did we obtain at the end? What we obtained, like the first point was definitely having an homogeneous architecture. We all had, in the past, we all had like all kind of different virtual machine communicating with each other with different patterns. Right now, we try to base everything on Kubernetes, and this makes our life much easier because the infrastructure is always the same. It's always homogeneous. It just changes what you are running inside the infrastructure and not your instance size and so on. It's very cost efficient. So as I said, the first reason that we went for Kubernetes in the beginning was also our CI. As I said, we manage very large CI. And this on Kubernetes allows us to have like 100 servers during the day and 5 servers during the night when people are not working, let's say. And even in this case, we don't have to waste resources anymore. We don't have to do much capacity planning anymore, because whenever my Prometheus is getting tight in terms of resources, I can just bump them in the deployment file, and automatically it will be rescheduled in a node that has more resources available. We improved security by a large extent. So before, we used to have all our instances out in the wild, so with the SSH port exposed. Right now, using the private network topology, everything is isolated from the outside. We have better handling of changing requirements. We really like the idea of namespacing in Kubernetes to create new environments for our developers and so on. And whenever you basically want to delete an environment, you just kubectl delete namespace, basically, which is really great because it automatically cleans up all the mess that you've done. And last but not least, easier and faster scaling. So you don't have to take care anymore about scaling up or down using AWS alerts that trigger events and so on. Kubernetes does that for you. If it sees that something that you're trying to schedule doesn't fit in a certain instance, it will automatically spawn a new one. And yeah, after that, Daniel was quite happy. So I also have a couple of more tips or things that we are doing. Some of them are very opinionated, but they work quite well for us, at least. So keep always one instance group for availability zone. This is really important, and it will bite you hard. At least that's what happened to us. So Kops always assume that instance group are always have the same capabilities. So whenever you are spawning an instance like a T2 medium in Europe, West 1A, it has the same capabilities of an instance of T2 medium in Europe, West 1B. And why you might think, yes, I mean, they basically are the same thing. This is not actually true because they cannot mount the same storage, for example. So if you have an instance group that is crossing multiple zones, what will happen is that the first time you deploy storage, your pod will be scheduled on a machine. It will create the storage in that zone. And as soon as that pod is rescheduled in a different zone, it will not manage to mount the storage anymore. And your pod will stay in this pending state forever. So always keep one instance group per availability zone. I suggest, I know that many people don't do that. They have multiple clusters per VPC. I honestly suggest you to use one cluster per VPC. This becomes really handy also for testing upgrades, for example. So whenever you're testing an upgrade, you can run the Terraform command again, see what is happening, see what Kops wants to apply, and so on. And this becomes really much, it really isolates the environments, and they should be. You want stage isolated from production. And that's why I suggest to have one cluster per VPC. This one is like, some people don't like this thing, but I will explain you why. Run your dev cluster all on Spot instances. This is something that we started to do a while ago. So basically, we run a whole cluster just on Spot instances. Why? There are 2 reasons for that. So actually 3. So the main motivation is that you don't have SLA. So you don't care if the cluster is unavailable for 30 seconds or 5 minutes. It's fine. Cost saving, so it saves a lot of money, especially if you have large cluster. But the main advantage is that you have sort of chaos engineering on the cheap. So, basically AWS will start killing your instances every now and then in an unpredictable way. And sometimes, you expect your cluster to be able to recover to a running state by itself. So you should not act for it. And this actually saved us several times. Sometimes you have bugs in software that are triggered only when you have really high dynamicity in terms of like servers created, destroyed, rescheduled, and so on. I can make you an example for that. Yeah, I have time. A while ago, there was a bug in WeaveNet. I don't know if anyone is using that. Basically, it's like a container network that we're using in our Kubernetes cluster. And Weave has this bug for which, when it would create a new node, would assign an IP, but it would never release it. So what we found out is that using this dev cluster on Spot instances, basically Weave was running out of IP to assign, and new nodes were not getting into the cluster anymore. We couldn't have found that in production because we don't have that level of dynamicity in our production cluster, but we found that in dev cluster. So really on the earliest stage, even before staging. And this was, this came for free on a cheap cost without impact for our developers, basically. And yeah, so this tip, you can do it as well. Many people don't like that, but I'm happy to discuss possible different solutions. Yeah, and you can even have some dynamically spawned nodes for CI. So what we do is that we have a dedicated availability group, dedicated instance group for our CI, where we have very powerful machine with a lot of memory, a lot of CPU, and so on. And we just have that group of instances run our CI and CD jobs, which are quite CPU and memory intensive. So yeah, I hope that you learned something today, that I managed to give you some tips and tricks about how to use Kops and how not to use that. More than happy to discuss some possible other solution if you're using Kops already, or if you have some more tips, or if you have some critics about what I said. Yeah, thank you very much for the attention. If you have any question, please raise your hand. One more thing. We are hiring, so please check out our page, because we are looking for more people to our team. Questions? Yeah.
Do you put your RDS instances in the same VPC as a Kubernetes cluster, or
do you put your what?
Your RDS instances in Elastic Cache in the same VPC as Kubernetes?
In this case we do. So basically we use the Terraform export, and using Terraform export you basically see all the security groups, and we say, okay, the security group of the nodes should be able to access on the private network our Elastic Cache or RDS and so on. Yeah. In this case, we try to keep the environment as separate as possible. This is why I suggested like one cluster per VPC. But yeah, then of course you keep like all the lambdas that are linked together, like all in the same.
And because if you tear down the Kubernetes and you tear down your RDS, because it deletes the VPC or once.
No, you don't need. No. With Kops you can specify different things. You can even say, okay, you can run in a VPC that is already created, but it's empty.
Yeah, so actually just a quick question from my side. What is the average lifetime of a AWS Spot instance? Is there something like an average lifetime?
It's actually I cannot really answer to you. I mean, I know that for Google Cloud, we're using Google Cloud much more extensively. So Google Cloud, there is no chance that your instance is going to last more than 24 hours.
Right.
For Google Cloud is much more strict on that. Like there is no way your instance is going to be up for more than 24 hours. For AWS, we have seen instances going up like for a week without being killed on spot instances. But it always depends on the size, on the location. There are so many different, there are so many different criteria that it's hard to like bring a baseline.
Cool. Thank you.
Thanks. Okay, that's it. If you have more questions, I will be here anyway. So thank you very much for attending, and yeah, have a nice Container Days.